Hi, this is Dr. Taheri, and this is our second Maple tutorial screencast. Previously, we talked about some basic function using Maple version 15, how to enter a function, how to solve, and we pick up from where we left. I would like to add a simple function here, x squared minus y squared divided by 9 equal to 16, and this is how it looks like. So I just want to plot that. So plot it in 2D, and this is its exact shape. Here I can actually come and solve this and define what is the variable, what is the function. So if I go to solve here, and I have here solve for variable, if I choose x, it means I solve x as a function and y as a variable, and this would be the answer. X is my function and y is variable. I can right click on it and I can go to solve, and I can go to variable and I pick y. In that case, y would be my function and x would be variable. As you can see, it's been solved here, and that's a good feature. So moreover, if I want to find an inverse of a function, that's also important. Sometimes you have y as a function of x, and then you want to switch the place of x and y, so x become the function and y become the variable. So in that case, let me just write here x fx equal to 2 multiplied by x to the power 3 minus 2 x to the power 2 minus 5. So this is my function here, and if I want to find the inverse of the function, in a sense I want to find if this the whole thing is y, and what would be x versus y. So in that case I used the solve command, and I would say solve x equal to fy comma y, and this would be the answer. Of course, it would be a complex. So what I have here, I have three sets of answers. The first answer here is this up to here, this one answer, and of course you can see that this is an imaginary answer. The next one would be starting from here. Actually, so we have three. One start to this comma here, the next one up to this point here, and I have one actual answer, the real answer, which is this value here, as I highlighted in blue. So I have three answers, two imaginary and one real. So Maple also allows you to find the function of a function of a function, and you can continue. So let's just have an example here. Kx is equal to 2 multiplied by x plus ln x, and this is the function here. I can plot this simple function here. You go here, plot, 2D plot, and this is how it looks like. And then of course, moreover, I can say that k, which was a function of x, it's a variable for another function. The function is y. K is equal to k squared minus ln of the sine of the k. I made a mistake here. This has to be the other way. Okay, and this k, by the way, I have to be small k. Okay, let's just enter it again, and this is my function here. I can plot this one here, right click, go to plot, 2D plot, and this has shape like this. And if I want to find here the y of k of x, so it means k, which is a function of x and itself is variable for y, how do I correlate between y as a function and x as variable? I type like this and I press enter, and this is how it looks like. Whenever I had k, it replaced the value of k, which is here, and I can simply go here, right click on it, and I can plot this as well. It would be a little more complex shape, something like this, which comes very handy. I can continue that. I can have another function in that y is a variable, and we have another function, and this can be continued as much as is required, depends on the problem. Now let's have another function here, z divided by 4 minus x squared divided by 9 plus y square divided by 16 equals to 25. So I don't write it equal now here. Let's just write like this here. Let's plot this first. If you're familiar, this looks like a saddle shape, like this. Right? And here I can simply come and again solve it for the variable I have here. I solve it for example, x. X is my function, the other two are my variable, and as you can see here, I can right click here, go solve, go variable, go y, and y is a function, and x and z are variable. Or I simply could go here and I could solve it for the variable z and the other two, sorry, the variable x and y, and the function is z. So this is a simple representation of it. Now, of course, using Maple, I can solve a series of equations, system of equations and variables. Let's just have two equations, two variables, x plus 2 multiplied by y equal to 12, comma, and x minus y is equal to 9. So I have two equations and two variables, and I can simply solve this, and I solve here. The answers are obviously 10 and 1, and let's just plot this and see how they look like, and this does it match our expectation here. So obviously I have two lines here, and you can see these two lines are intersecting. Maybe I change my axes here, so instead of here I go from 8 to 15, apply that, and as you can see here, this is the intersection of these two lines, which is the geometric representation of the two equations, two variables. You have two lines, and of course there are different scenarios. Maybe they are parallel, there is no answer. Maybe they are the same, there are infinite number of the answers, or maybe in this case they are intersecting in one point, and this is the point. I can do the same thing in a 3D, so I can write x plus 2 y minus 5z equal to 12, comma, x plus y plus z is equal to 3, and x minus 6y, I'm just making it up, plus 2z is equal to 4. So I have three equations, and these are my three equations. Let's see if I can find the answer here. So right click on it, solve, and you simply go and solve here, and these are the answers. And if I want to plot these, so obviously I go here to plot and XYZ plot. So I have three planes here. You can see these three planes, and these three planes, they will intersect in one point. Of course, it's not shown in this particular graph, but imagine if you want to find make it kind of more understandable, these two, this top plane and this one, they have a line as intersection. Two planes, they meet in a line, and then this line intersect with the third one at a point, and that's what we get here. Now of course this is a simple example, but you can have more than three equations, three variables, and more interesting and complicated, this could be non-linear. So let's just copy and paste here this equation, copy, and I'm just going down here, and I go here, paste, right click, paste. Oh, for some reason it didn't work. Right click, paste. Okay, let's just give it a space here, and in this case, maybe instead of here I will use z to the power 2, and here instead of y I like ln y. So this is a much more complex, and there is actually not an easy way to solve this. So let me just plot this first, and I can see that, well, obviously it's a little more complex here, and maybe we don't even have an answer for this, or not a real answer for it. So if I go solve here, and here is the answer as I expected. And if I want to even find a numeric values, most probably I won't be able to find a numeric value for the answer, which is that's reality. Now, one thing also is interesting here. At this point, I can simply go and I can solve this, and in this case, I can eliminate a variable. I can eliminate x, and here what I get. So it means from one equation I have the x, and from the other two equations I remove x. I could have simply go here and I can solve, and I can go here, eliminate, and I eliminated y. This should have been more complex here, or I could have done the same thing about z. And as you can see that these are very powerful functionality of Maple version 15. Previous version you could have done that as well, but I'm just talking about version 15. They have more features in this. One thing I would like to explain, in the very first our previous screencast, we didn't talk about this variable here. What Maple does is keep record of all the variables and functions you have introduced. So if I go to variables here, and these are what we have here. So remember here we have this function, we have a k as a function of x, and this was the equation here. If anywhere I use here, for example, k2, and it gives me the answer here. It replaces k, wherever you have x, you place 2, and then you can find this, and you can right click on it, and you can simply find the value. If I want to use k in different way, I have to define it again. I have to use perhaps k is equal to kx is equal to x, and from now on, of course, this will be added, and I can simply go here and I can look at it, and previously it was different. Now kx is a function that makes kx equal to x. So this comes actually handy, but if you want to repeatedly using a function, you have to keep track of it, or you have to add the new one so it replaces the previous one, or you use a new actually symbol for it. And this here we end this screencast. There will be quite a few more. We talk about some other functionality using Maple version 15.